Welcome to another Blender tutorial. My name is Chris, and in this video I will show you how to emit particles from particles, how to change the material based on the age of a particle and the issue we are facing with this, how to have particles follow a smoke simulation, and how to have certain particles only be affected by certain force fields. Let's do this! Okay, I assume you are familiar with particle systems in Blender, so I'm gonna just take the default cube and turn it into a particle emitter by adding a particle system. Let me also switch on screencast keys so you will see what I'm doing down here. Okay, so now if we hit play, the cube is emitting particles and they're all falling down. And that is because we have the field weights here. And we can turn down the gravity for just this single particle systems. So now the faces are emitting particles. We can change the lifetime here to say like lifetime of 100 frames and randomize it by 0.9. This essentially means that the maximum lifetime of a particle is 100 frames. The minimum lifetime of a particle is now 10 frames. And each particle has its own lifetime, own random lifetime. Now, just to make this more interesting, I'm also going to add a force field turbulence, which looks like this in the scene, like an empty. And we can set the turbulence, maybe increase the strength a little. That just gives us more interesting looking particles. If I split the screen here and turn this side here into rendered view, and switch over to Cycles, GPU, and switch the viewport rendering to none. You can see that there is nothing there. The particles are still here, but they're just a virtual thing. They don't have any mesh or geometry. There's nothing to render here in the Cycles viewport. So how can we get something that we can actually see and render? Let's just create an icosphere. This guy here, and now switch over to the cube and tell the particle system, instead of a halo or nothing, render an object, please render the icosphere. So now if I switch the viewport display to rendered, you can see that the cube here is now actually emitting all sorts of these icosphere. The size can be set here, and we can also randomize the size so that it looks even better. And this is basically how you have a particle system in Blender. And before I continue now to show you how to emit particles from particles, I want to show you something else first, and that is the material setup, because there will be a problem with this later. So I think it makes sense to talk about it right now. So let's go select the icosphere, give it a new material, and so if I set this to red now, we have red particles because I'm changing the material of this one icosphere here. Now there is a node in here which is called the particle info node. Like I said before, each particle has a lifetime, it has an age, which is also measured in frames. It also has an index, a random value, and all sorts of information. And we can use that information in the material here. For example, we could change the color of the particle according to its age. Now, the age output here is a frame number. So remember, each particle might even have a different lifetime. And that's why we have the lifetime output here. And it's all in frame numbers. So if we want to use this as a factor of a color ramp, we first have to do some math here. And that's not really very difficult. We just use a math node, set it to divide, and we divide the age by the lifetime. Now we have a factor between 0 and 1. Why? Because, of course, let's say a particle has a lifetime of 50 frames. The age is either 0, so 0 divided by 50 is 0, or the age at some point will be 50, and then 50 divided by 50 is 1. So this is now a factor between 0 and 1, perfect to plug into a color ramp. Now we plug this color in here, and you can already see it's doing something. So brand new particles are over here, black, and then particles, older particles, will be white. So let's create something interesting. Maybe a bright white. Then we add a yellow, like so. Then we add like an orange, add a red. I'm thinking fire. You know, this is like the color setup you will probably have for something like embers of a fireplace. And now you can see when the particle is born, it's white, then they turn yellow, and at the end of their lifetime, like this one here is very old, it turns into black. Let me also switch this shader out to an emission shader. So we have this cool looking thing. Now we could also use different particle information, like for example the velocity, which is a vector, and we could do a vector math. Where is it? Vector math. Take the velocity, calculate its length, for example, and use that to drive the strength, maybe with another math factor in between here. You get the idea. We have this particle info node, and we can use that to actually change the color of each particle or change the material. Okay, cool. That's what I wanted to show you, because now I'm going to go back to the 3D viewport and I'm going to show you how you can emit particles from particles. So the first thing you might think of is, well, very easy, right? So this cube is emitting these icospheres. So let's just select that icosphere and add a particle system to this, right? Go back to frame 1 and hit play. And we can see that this is obviously totally not working. These particles here are just being emitted from this icosphere, not from all of these particles. Now, why is that? The particle emission needs a source, and the source can be the vertices, faces, or the volume. So it needs a mesh, it needs geometry to emit particles from. The only geometry we have here in this scene of this icosphere is this icosphere, because this particle system over here just takes this mesh and creates like instances, duplicates, but it doesn't create a real object in our scene in Blender that has real mesh that can emit particles. So this particle system on this icosphere is useless. This is not how it works. Okay, let me create a new icosphere and leave it right in the center there. So it's basically inside of the cube. That doesn't matter. So instead of telling the particle system of the cube to render an object, we just tell it to render nothing, maybe. They're still there, but we can't see anything, okay? Instead, we click on the icosphere and we tell the icosphere by using the particle instance modifier and picking the cube object which has the particle system on it. We tell the icosphere to duplicate itself inside of this object. So we're creating this particle instance modifier is actually creating mesh, and it's creating itself or duplicating itself inside of the mesh where the particles from this particle systems are. By enabling the size, we also get the size information from the particle system, and we only want the alive particles. We don't want the unborn or the dead. So we're back to what we had before. So we have a cube emitting particles, okay? But you can see now, this is the cube, and this, when I select this, this is all of those particles. This one object, the mesh inside of this one icosphere, is now all of this we don't have that one single icosphere on the side here anymore, because this is now the icosphere. So we have real mesh, and that's what the particle instance modifier does for us. It creates real mesh. Now let's select that real mesh and go to the particle settings here. And now we can add a particle system to all of these particles. And if I go back and hit play, we now have nothing yet, because we have to enable use modifier stack. These particles here are only here because of this particle instance modifier. So we have to tell this particle system, hey, use the modifier stack. And now we have particles coming out of these particles. Okay, let me select the cube again. This is maybe a little bit much. Let's just do 100 particles. Now, okay, now over in the viewport here, we still need to render something for these particles, for the tiny ones now. What can we do here? Well, how about we create another object, maybe, I don't know, donut. Everybody knows that Blender and donuts kind of belong together. So let's take this particle system from our first set of particles and tell it to now emit an object. Which one? The donut. So now we have donuts coming out of our particles here. And of course they're falling down because this particle system here still uses gravity. So maybe we turn it down to a 0.1, which makes them fall down a little slower, or maybe we turn it off, which means those particles are just gonna stay, or they're just gonna be emitted from the surface, and they have a speed coming off of the surface, which is set here. The velocity, if we set that to 0, basically our tiny spheres here, they're emitting those particles. The particles are influenced by this force field here. So this force field not only influences our bigger particles, it also influences the donuts, of course. So now everything is flying around like crazy. Okay, so this is how you emit particles from particles. You just saw that I told this particle system to use instance object the torus. So now again, I can't go here and tell the torus to again emit another set of particles. If I want to do that, I have to, just like I did now, we tell this particle system to emit none or render none, and we tell the torus, hey, you need a particle instance modifier, and the object that has the particle system on it is now this. Now we have a lot of donuts. Again, we want the size. We only want the alive particles. And now we have this. So we can play this. Now it slows down the viewport quite a bit. This is not as efficient as a real particle, but that's what you have to do if you want particles emitted from particles, like you can see here. Now we can go in. Since this is now one big mesh here, all of those little donuts, we could go in again and add another particle system on top of this. And then we have particles emitted from particles emitted from particles. So this is how you do it. Now let me just undo this quick. So I take away this modifier and tell this particle system to actually render, where is it? Render an object, the torus, and it should be working again. Yes. So now I can take this guy and move him out of the scene here. All right. So this is what we have so far. Now let's go back to the material because there is an issue now. Let's see. Shader editor. Let's select the icosphere. We lost the material, so let's just take our material that we had right here, which uses the particle information. And you can see there is something wrong here. They are all just white, which means this particle info node is basically not working anymore. the factor that we get here is always this white, so it's 0. This output, this particle info node isn't working because now we don't have particles anymore. We have an icosphere object, and all of those spheres here that we see are real mesh inside of this object. There is no more particle information because we're not creating those particles with the particle system by telling it to render an object here. We're rendering nothing. We're telling the icosphere that it should be using the particle system. So we lost this cool feature. Now, when I was playing around with this, I kept thinking, why doesn't this modifier here store this particle information somehow in the mesh, in the icosphere mesh? So for example, this modifier here could store the age or the lifetime or the index or the random, any of these values inside of a vertex color slot. You know, you can go over here and inside of a mesh, you always have vertex colors. You can add a vertex color slot, you can vertex paint and whatnot. So why doesn't this modifier store this information inside of the vertex color so we can use the vertex color in here to get this feature back somehow? Then I realized, the developers of this modifier already kind of thought of this idea because they have these two options down here, the index layer and the value layer. And when you look up the particle instance modifier and you scroll down here, you can see that the index layer is a vertex color layer for values based on the particle's index, and the value layer is a vertex color layer for random per particle values. I don't know why this isn't called random layer, but it's called value layer. So basically, what we can do here is we can get this information and this information from this particle instance modifier. Okay, so let's do this. We add a vertex color slot. Let's call it rand. Go to the modifier and tell this value layer, which should be called random layer, because it's putting this random information, a random number per particle, into this vertex color slot now. Okay, so it's filling this slot, gives us a random value. And how do we use values from vertex colors in materials? Always with an attribute node. We put in rand here, so the name has to be the same as here. And now we get a color, and we have random values. So some of them are black, some of them are whites, and some of them are gray. And if I hit play, each of these, of the first set of particles, that's the only thing I'm working on right now, they have a random value now. We could do the same thing for the index, so we could have this information. Sadly, there is no option here in this particle instance modifier to give us any of these cool features here. Okay, so we have a little bit of a variation because of these two, but we lost our age and lifetime feature here. Now if you're interested, or if you think like me that this modifier here should provide these options as well, the age, lifetime, maybe the velocity, then maybe you want to head over to this link here, where I just recently created this proposal for the particle instance modifier to actually give us these options so we can get our cool age, ember, whatever effect back for the age of a particle. It would be as easy as doing something like this: age, lifetime, tell the particle instance modifier over here to put the age into an age vertex color slot, the lifetime into a lifetime vertex color slot, and then do the same thing here. Divide this factor and this factor, and then we have the same feature here. And that's what I would like to see. so that this particle instance modifier can be way more useful. Again, if you agree, if you want this in Blender, let's make it happen. Go over to this address. I'll put this in the video description below the link, and then upvote this proposal. All right. Okay, now let's talk about something else. How can we have particles follow a smoke simulation? I'm just going to start with a new scene here. Take the default cube again, add an icosphere again, create a particle system on the cube. Okay, do 100 particles, turn off gravity. What does that look like? Okay, cool. We want a little bit longer lifetime. We want random lifetime. Okay, so let's keep this simple. Now let's add an icosphere. Let's create this particle instance modifier based on the particle system of this cube, using the size only the alive particles. Okay, if we go back to the particle system here, we can change the scale here so we get a little bit bigger particles. Now remember, all of this is a real mesh now in this icosphere. Now I select the icosphere, I go to object, where is it? Quick effect, quick smoke, which creates a smoke domain object for me. Maybe scale it more like this. And now each of those particles is emitting smoke, basically. So if we go back to frame 1 and hit play, ooh, we can already see the smoke. And you can see the particles are actually emitting the smoke. So maybe let's do a little bit more interesting stuff here. Maybe increase the velocity a little so that they fly out faster. Again, I'm going to add a turbulence. Whoops. I'm going to add a turbulence force field. Increase the strength a little so that we get more interesting looking stuff. Let's select the icospheres, go to the smoke flow settings over here in the smoke simulation and turn the temperature difference to something really small because the smoke is rising a bit fast here. Okay, so now the smoke just sticks around wherever the particle was. I'm also going to select the smoke domain and enable dissolve for like 15 frames. So now the smoke should dissolve over time. Yep, it does. Okay, so now we have smoke. You know what? I'm also going back and setting the temperature difference maybe higher, so we do have some smoke rising here, because now we not only have this particle system that's emitting the smoke. The interesting part is, how can we have a particle system follow this smoke? So let me just create a plane, maybe move it over here, and add another particle system to this plane. Again, I'm going to switch off gravity. Okay. And if I hit play now, basically they're all just flying up. Why are they flying up? Because we have a velocity on the normal. So if we don't do this, now these particles are just being thrown around a little bit by this force field. That's all. Okay, now we want these particles here to follow this smoke simulation. So basically the hot air is rising, so we want these particles to be pulled up here. How do we do that? We have to add a force field, smoke flow, and that's, it just looks like the other force field. They all look like empties. And then in here, the smoke flow force field needs a smoke domain object, which is this cube. So let's just pick this cube. Now this field tells the particle system, or all of the particle systems basically, to influence the particles by the smoke from this smoke domain. So what does that look like? Okay, so we have, oh, we can see it's doing a little something. So if I move this plane over here, see, it's pulling the hot air from the smoke, is pulling these particles up. Okay. And that's how you can have particles follow a smoke simulation. But there is an issue here, because now both force fields in our scene here are influencing all of the particles. So how can we limit a force field to a certain particle system? I don't want the smoke flow force field here to influence these particles. They should just do their thing, and these particles should follow the smoke simulation. And there's an easy way to do this. So let's pick this one. That's the turbulence. Okay. I hit M, new collection, and I'm going to call it forces 1 because it's for my first particle system. So the turbulence should only influence these particles, maybe. And then the smoke flow, I'm going to move to a new collection and call it forces 2. Okay, and now it's really very easy. We go in here. So the particle system of the cube, scroll down here, and we say, hey, we only want the effectors, the force fields of forces 1, and then on the plane here, emitting these particles, we only want forces 2. Let's go back, hit play. So now, the turbulence influences these particles. They are not following the smoke simulation, they're creating the smoke simulation. And the smoke flow force field over here influences these particles coming from this plane. And we can see that the hot air is pulling the particles up like this. So with this effector collection here, you can determine which force field or force fields, because you could have many, influence the particles of which particle system. Now let's quickly look at this scene, and you will find everything that I just explained in here. This is the scene of the animation you saw before. So let's go to frame 1 and look at this. So I have a plane here that is emitting particles. And the reason why these particles are going to fly over to the right here is because I have a force field in here, which is just a force with a strength of -2, which means it attracts particles. So this particle is going to fly over here. It's going to overshoot and then fly back and overshoot and fly back. And all these particles emitted from this plane here are going to do that. So let's look at this by disabling these two. Let's just look at this icosphere. Right, so they're being emitted. They're being attracted, and the way this icosphere is set up is it has a particle instance modifier on it with just the alive particles, which means that this can have its own particle system on it, emitting these particles. Now these particles, again, if I enable it over here, these particles, I gave a blue, or a little bit randomized blue color. So they again are just an icosphere with another particle instance modifier on it. And they again have their own particle settings or particle system on it. And they are rendering an object. So the final set of particles, which is this set here, the tiny orangey particles here, and they're actually being rendered. So they have a material set up with the H feature that I showed before, and I'm using the velocity to power the strength of the emission, just like I showed. So this is the material of the blue spheres. I'm doing a little bit of a random variation on the blue spheres, and then this is the material of the big spheres, these, the first level of particles basically, where I'm just creating this outer rim. This is basically a sphere that is transparent in the middle and has an emission shader on the outside, set by this color ramp based on the facing value of a layer weight node. So that's that. Now let's go back over here. You can see here we have the forces, we have the force field, this force field that's attracting the big spheres. So basically the particle system of this plane here is limited down here to only use forces 1. And then we have forces 2, which is this force field, which is a smoke flow. So what I did here was those big particles, those big round spheres, they are emitting smoke inside of a smoke domain, which is this here. So they're creating smoke, and the smoke that they're creating, I'm then using in the forces 3 for the teeny tiny particles here to make those tiny orange like embers follow the smoke simulation. So that's really all there is to it. This is how I put together this animation. Particles in Blender are so much fun, I love them. And there are many cool things being developed in the functions branch. This will be epic. If you're interested in how to get a bullet time camera rotation effect like this one, then do subscribe because I'm working on a separate video for this. And by enabling the notification bell, you will be the first to watch it when it drops. If you enjoyed this video, a sub is really appreciated. Like, share, comment. Oh, and as always, the finished blend can be downloaded on patreon.com/crispy. That's it, Crispy out.